Is screen visible to you? Hello?
Yes, ma'am. Yes, visible.
Okay. So last time just we have seen question number 1. So today we are going to see some more examples based on Cartesian product. So before that I want to revise what is the order pair and Cartesian product. So I want reply from you. What is the order pair? What is meaning of order pair? Last lecture we have seen what is the difference between set and order pair. So what is the meaning of order pair? Pair means what? It is consist of two elements and those two elements will be in fixed order. That's why that is called as ordered pair. Okay. After that we have seen definition for Cartesian product. So suppose there are two different sets A and B, then for every order pair x comma y, x must belong to set A and y must belong to set B. Then set of such order pairs x comma y is called as Cartesian product of A and B. Okay, so last time we have seen that. So here one example is given. If set A is equals to A comma B, B is equals to B comma C, C is equals to 1 comma C, then find A Cartesian product B union C. So can you tell me how we can solve this example? What we have to do? Okay, so here first of all we have to find out what is the B union C. So now tell what is the answer for B union C. Just we have to combine the elements from set B and set C. So BC1. So this is the answer for B union C. Now we have to take Cartesian product of A with B union C. So now check what are the different members of set A. Those are A and B. So A comma B Cartesian product B comma C comma 1. Now we have to take Cartesian product between these two sets. So first of all consider first element of set A and that element is A. So first order pair would be A comma B, then again A comma C, A comma 1. Now check for the second element of set A and that element is B here. So B comma B, B comma C and B comma 1. So this is the answer for A Cartesian product B union C. So likewise we have to find out next A Cartesian product B union A Cartesian product C. So here first of all we have to find out the answer for A Cartesian product B. So can you tell me what would be the answer for A Cartesian product B? Hello? Hello?
Yes, ma'am.
I want answer for A Cartesian product B. How you can define it? It is so simple. Just again for A Cartesian product B, we have to consider first element of set A and that element is A. So small a. Again here we can write order pair A comma B, again A comma C. Now we have done processing for the first element of set A. Still second element is remaining. So again B comma B and B comma C. So this is the answer for A Cartesian product B. So likewise you have to tell me answer for A Cartesian product C. What would be the answer for A Cartesian product C?
A comma 1, A
Yes.
comma C, B
Yeah.
comma 1 and B
B
comma
comma
C.
C. Yes, that is correct. Now, what they have asked us, we have to take union between these two Cartesian products. So, whatever order pairs we have got from A Cartesian product B and A Cartesian product C, we have to take its union. Means what? We have to combine all the order pairs from these two Cartesian products. So, our final answer would be A comma B, order pair A comma C, B comma B, B comma C, and A comma 1 and B comma 1. So, here A comma C and B comma C, these are two order pairs, those have repeated. So, we are going to take it only once. Now, next question is A Cartesian product B intersection C. So, in order to solve this example, what would be the first step? What we have to find first?
We have to find first B intersection.
B intersection C.
Yes, B intersection C. So, again for this intersection, we have to look for common element between B and C, and that element is C here.
C.
So, now find out A Cartesian product C. So, A is containing two elements as A comma B. So, first order pair would be A comma C and second would be B comma C. Okay. So, this is the answer for A Cartesian product B intersection C. Now, next one is A Cartesian product B intersection A Cartesian product C. Now, here we have find out what is the value for A Cartesian product B and A Cartesian product C. Now, we have to check whether there is anything common between these two Cartesian products. Now, check whether any order pair is common between them.
A comma C and B comma C.
Yes, A comma C and B comma C, correct. So, this is the final answer for this intersection. Are you getting this?
Yes, ma'am.
Okay. So, in the third question, they have asked three sets are given as A, B, C, and we have to find out A Cartesian product B, Cartesian product C. Till now, we have just seen Cartesian product between two sets, but in this question, they have asked Cartesian product between three sets. So, how to solve these kind of examples, we will see. So, first of all, we have to find out A Cartesian product B. Okay, that we can easily find. So, first order pair 2 comma 1, then 2 comma 2, 2 comma 3. Then for the second element of A, that is 3, 3 comma 1, 3 comma 2 and 3 comma 3. So, till now we have find out A Cartesian product B. Now, we have to take its Cartesian product with C. Okay. So, again now we have to consider this A Cartesian product B as a first set. Okay. So, here 2 comma 1 order pair 2 comma 1 will be first element of that order pair. So, 2 comma 1 comma 1, this will be order triple. Okay. Are you getting this? Why this one is a order triple? Because here first element of this order pair is order pair itself, because here first we have find out value for A Cartesian product B, and that will give you order pairs. Again we have to take its Cartesian product with another set C, that's why it will give you order triple. Okay, that's why 2 comma 1, this is a order pair. Now order pair 2 comma 1 comma 1, this is the first order triple. Then 2 comma 1 comma 3, this is second. Then 2 comma 1 comma 4, this is third. Again 2 comma 2 comma 1, 2 comma 2 comma 3, 2 comma 2 comma 4, 2 comma 3 comma 1. Likewise, we have to take all these ordered triples. Then only you will get answer for A Cartesian product, B Cartesian product, C. And symbol, or we can say syntax for order triple is like this. This is called as order triple whose first element is order pair itself. Okay, so write like this way. You have to write these order triples. Hello, have you understood why order triples are here?
Yes, ma'am.
Okay. Now, in the next question, they have asked us to find out set A and B. So here they have given Cartesian product between A and B, and from that Cartesian product we have to find out what is the set A and what is set B. Okay. So as we have seen, for each and every order pair, the first element of that order pair must be element of set A, and second element of that order pair must be element of set B. Okay, so if you observe, we have to find out what are the first elements of each and every order pairs. So first element is 6 here, again 6, 6, then 1, 1, 1. So we can say that set A is consist of two elements as 6, 1. Now check for the second element of each and every order pair, and those elements will belong to set B. Now check here, 2, 3, 4, 2, 3, 4 means what? Again we are not going to consider repetition. So 2, 3, 4, these are the elements of set B. So likewise, from any Cartesian product we can analyze what would be the elements of those sets. Okay. So in the question number 5, they have given two sets, and from that we have to find out different Cartesian products. So in the first question they have asked A Cartesian product A. So tell me answer for A Cartesian product A. We have to take Cartesian product of that set with itself. Be quick. So what would be the answer for A Cartesian product A? Consider first element A, and we have to take Cartesian product of that element A with all the elements of another set, and here that another set is A only. Hello? Hello? Are you able to solve this? Okay. So we will see. Here we have to find out A Cartesian product A. That's why we have to consider Cartesian product of this set with itself. So first element is A. So we have to take A comma A as a first order pair, then A comma B, then A comma C. Okay. So till now we have done processing for this first element A. Now consider second element, and that element is B here. So again B comma A, B comma B, B comma C. Now just one element is remaining, that is C. So C comma A, C comma B, C comma C. So this is the answer for A Cartesian product A. Now next one is B Cartesian product B. Now at least try for this one, B Cartesian product B. Take 2 minutes and tell me what is the answer for this Cartesian product.
B comma B, B comma C, B comma A.
Okay. Next,
C comma B, C comma A, C comma
C comma B, C comma C, C comma A. Then
A. And A comma B, A comma C, and A comma A.
is correct. Fine. Now next one is B Cartesian product A. So again we have to take first element as B. So now here first set is B. So first of all we have to check for elements of B only. So B comma A, B comma B, B comma C, then C comma A, C comma B, C comma C. Then A comma A comma B and A comma C. So this is the answer for B Cartesian product A. Now next one is A Cartesian product B. So you have to tell this answer, A Cartesian product B. So here which set we have to consider first? They have asked A Cartesian product B. That's why we have to consider set A first. So again that set is containing 3 elements. From those 3 elements we have to consider first element A. So A comma B, A comma C, A comma A, then B comma B, B comma C, B comma A, then C comma B, C comma C and C comma A. So this is the answer for A Cartesian product B. So now in the next example they have asked whether there is anything common between A Cartesian product A and B Cartesian product B. Now check whether there is anything common between A Cartesian product A and B Cartesian product B. Yes, some common terms are there, like A comma A is there, here is also A comma B, A comma B, A comma C, yes, that is present here also, B comma A, B comma A, B comma B, again B comma B, B comma C. So here all terms are common between A Cartesian product A and B Cartesian product B. So answer for this intersection is either A Cartesian product A or B Cartesian product B, because all the terms are common between these two Cartesian products. Now in the next one they have asked the Cartesian product between B Cartesian product A, intersection between B Cartesian product A and A Cartesian product B. Now check whether there is anything common between these two Cartesian products, B comma A, but here that term is A comma B. So check here whether anything is common between these two.
Madam, B comma A is present now.
B comma, where is
B comma A.
yes, that is present here, B comma A. Then B comma B is that is also present here. B comma C is that is also present here. C comma B that is also present. C comma C. Then A comma A that is also present, A comma B, that is also present, A comma C. Now check here whether A comma C is here.
Second term.
A comma C. Okay. So again we can say that all the terms are common for these two Cartesian products. So answer for this intersection is either B Cartesian product A or A Cartesian product B. Okay. So have we understood what is the concept of Cartesian product? I think these much examples are sufficient for this point Cartesian product. So here we have completed unit number 3, set theory. Okay. So if you are having any doubt, you can ask me. So we will revise it. Otherwise, we will start with unit number 4. If you have any difficulty, then ask me. Okay, so I will consider that you don't have any difficulty. So we will start with the next chapter, that is unit number 4, relations. Unit number 2 is remaining, but we will see that unit later. So this is the unit number 4, relations. So here first we have to see what is the syllabus for this unit. Here they have given definition for relations, then properties of binary relations, then matrix and graph representation, partition and covering of set, then equivalence of relations, composition, poset, that is partially ordered set, and Hesse diagram. So this unit is quite lengthy. We will cover it. So these are the some assignment questions. Okay, so we will start with the definition of relations. So in the last chapter, that is in set theory, we have seen what is meaning of order pair. So relations we can define as set of order pairs. Okay, so its definition is so simple, just you have to write set of order pairs. Okay, then what is the order pair we have already seen. Now they have given definition as a binary relation R from set X to set Y is written as X R Y. So what is meaning of this X R Y? X is in relation R with Y. Okay, or R comma X, R in bracket X comma Y means what? This relation R is applicable to X and Y, is a subset of Cartesian product X Cartesian product Y. So meaning of this statement is same as a relation is set of order pairs. Okay, now suppose there are two different sets A and B, those are having cardinalities M and N. Okay, so in this set theory itself we have seen what is meaning of cardinality. So cardinality means the number of elements present in those sets. Now here they have given cardinality for A and B is M and N. Then maximum cardinality of relation R from A to B is M into N. Means what? suppose your set is containing 2 elements as 1 comma 2 and B is containing 3 elements as 1 comma 2 comma 3. Okay, then we have to find out what would be the maximum number of elements in relation R. So that can be find out by using this formula as m into n, where here value for m is 2 and value for n is 3. So 2 into 3, that is equals to 6. Means what? 6 elements would be there in relation R. Okay. Now we have to see the next concept as domain and range of relation. Okay. So first of all, we have to find out what is the domain of any relation. If there are two sets A and B and relation R have order pair x comma y, then domain of R, D of R, that is domain of R is the set X for all order pairs x comma y belongs to R for some y in B. Okay. So what is the meaning of this domain? If there is any relation R and that is consist of order pair x comma y, then domain of that relation is first element of each and every order pair that is given here. Now check here, for this order pair the first element is x, that's why set of all first elements, it will constitute domain of that relation R. Okay. Now next one is for range. Now range we can define as set of all second elements from each and every order pair. Okay, that's why range of relation R, and that is written here as R of R, that is range of relation R, is a set which is consist of y for all order pairs x comma y belongs to R for some x in A. Means what? This range must include second element of each and every order pair. Okay. So keep in mind that domain always refers to first element of each and every order pair and range refers to second element of each and order pair of that relation. So here they have given one example. Set A and B are given and case 1 is given as if relation R is equals to, then R is equals to order pair 1 comma 1 3 comma 3. So relation R is given and from this relation we have to find out what is the domain of this relation and what is range of this relation. Okay. Now for this domain we have already seen domain refers to first element of each and every order pair. Now consider here the first element of this order pair is 1. So 1 should be included in domain of this relation. Again for second order pair first element is 3. That's why 3 must be included in domain of this relation. Okay. Now next we have to find out what is the range of this relation. So for the relation we are going to refer the second element of each and every order pair. So 1 comma 3. 1 is the second element, 3 is the second element. That's why 1 comma 3. So here domain and range of this relation is set 1 comma 3. So likewise we have to find out the domain and range for this second relation. So relation R is given and which is equals to less than. Okay. For this less than relation they have given R is equals to set of this order pairs 1 comma 3, 1 comma 7, 2 comma 3, 2 comma 7. Okay. So for this relation you have to find out what is the domain and range. So can you tell me what is the domain for this relation R? Hello. What is the domain for this relation?
1 comma 2.
1 comma 2, correct, because domain refers to first element always, that's why 1 and 2. And what is the range?
3,7.
3 comma 7, correct. So again, in the third case, here that relation is greater than, means what? First element of that order pair must be greater than second element. Now check whether this relation satisfies this greater than property. So 2 comma 1, 9 comma 1, 9 comma 3, 9 comma 7. So for all these order pairs, it satisfies the property greater than. So again, for this relation we have to find out domain and range. So for the domain 2, 9, okay, and for range 1, 3, 7. Okay, so this is the concept of domain and range of relation. Have you understood it?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, fine. Now next point is very important, properties of binary relations. So there are 5 different properties they have defined for relations. So first property is reflexive, then second one is symmetric, then third one transitive, fourth one irreflexive, and last one antisymmetric. Okay. So for each and every relation we have to check what are the properties satisfied by this relation. Okay. So first property is reflexive property. So definition is given as a binary relation R in set X is reflexive if for every X belongs to set X, X is in relation R with X, that is order pair X comma X belongs to R. Okay. So this is the definition for reflexive relation. A relation is said to be reflexive if for every element of that set X, if X comma X, this is the order pair, that is if order pair X comma X belongs to R, then only we are going to say that that relation is a reflexive relation. Now suppose relation R is defined as order pair 1 comma 1, order pair 2 comma 2 on set X where X is containing elements 1 comma 2. म्हणजे काय 1 and 2, these are the elements of set X, and from this set X we have defined one relation and elements of those relations are 1 comma 1 and 2 comma 2. Now we have to check whether this one is a reflexive. Okay, so here that relation is reflexive. Why? Because for all the elements of set X, आपण काय म्हटलं set X मध्ये दोन element आहेत 1 and 2. So for 1 there is order pair 1 comma 1 in relation R, and for second element 2 comma 2 is there in relation R. So it satisfies for every X comma X there is order pair X comma X which belongs to R. That's why that given relation is a reflexive relation. Okay, so for that we will see some example. So here they have given set and that is containing 4 elements as 1, 2, 3, 4. Okay, and we have to check whether this relation is a reflexive relation. Okay, so here they have given the relation as 2 comma 2, 2 comma 3, 2 comma 4, 3 comma 2, 3 comma 3 and 3 comma 4. Okay, so all these order pairs defines relation R. Now we have to check whether this one is a reflexive relation. What we have seen in definition, for every X, आता small x कोण असणार आहे इथे, all the elements of this set. Now this set is X, capital X. So for first element X, there should be order pair X comma X. Means what? if that element x is 1, then there should be a order pair 1 comma 1 that belongs to this set. Now check whether there is any order pair 1 comma 1. No. Again check whether 2 comma 2 is there for this second element 2. Yes, 2 comma 2 is there. Now check whether for this element 3 comma 3 is there. Yes, that order pair is present here. Now check for the next element 4, whether 4 comma 4 is here. No. So this relation is not reflexive. Why? Because order pair 1 comma 1 and 4 comma 4 are not here. If it includes all the order pairs as 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, then only we are going to say that this relation is a reflexive relation, because we have to check for all the elements of that set. It should include x comma x, then only that relation satisfies reflexive property. Have we understood what is meaning of reflexive? This point is very important. If you are not getting, then tell me, I will repeat it once again.
Ma'am, repeat again.
Okay. So first we will see what is meaning of reflexive property. Here, a binary relation R in a set X. So here this X is in capital, means what? This is a set, is reflexive if for every small x. So what is meaning of this small x? Small x means what? The element of this set X. So for if every x belongs to X, X is in relation R with X. That is, if order pair x comma x belongs to R, then only this relation R will be called as reflexive. Okay. So for that purpose, here some examples are given. So here set X is given, and that set X is containing 4 elements as 1, 2, 3, 4. Okay, and they have defined one relation R that is containing these order pairs. Okay, and now we have to check whether this relation is reflexive relation. Okay, so when we are going to say that that relation is reflexive, we have to check whether for all the elements of set X, order pairs are present such that x comma x belongs to R. Okay, so if you consider first element, 1 is there, so order pair 1 comma 1 must be in relation R. Again 2 comma 2 must be there, 3 comma 3 must be there, 4 comma 4 must be there. Then only we are going to say this given relation is a reflexive relation. But if you observe, here only 2 order pairs are present, 2 comma 2 and 3 comma 3. 1 comma 1 and 4 comma 4 are missing. That's why this relation is not a reflexive relation. Now understood what is meaning of reflexive? Hello?
Yes, ma'am, yes.
Okay. So, can you tell me whether this second relation, that is a relation given in question B, whether it is reflexive. Again, this relation is defined on same set that is containing 4 elements 1, 2, 3, 4. Now check whether this one is a reflexive.
Not reflexive.
Why not reflexive?
Three comma 1, 3 comma 2 is not there. 4 comma 1, 4 comma 2.
4, 2. What I said, what is meaning of reflexive? Reflection म्हणजे काय? जर तुमचे आता तुम्ही म्हणता की मिरर मध्ये किंवा पाण्यामध्ये तुमचं रिफ्लेक्शन दिसतं. रिफ्लेक्शन म्हणजे काय? तुम्ही जसे आहात तसंच दिसतं. दॅट इज कॉल्ड एज रिफ्लेक्शन. आता जर तुम्ही फर्स्ट इलेमेंट कन्सिडर केला ह्या ऑर्डर पेअरचा, तर तो इलेमेंट काय आहे? 1 आहे. मग त्याचं रिफ्लेक्शन काय असणार आहे? 1च असणार आहे ना. सो 1, 1 must be there in relation R. Okay. Again, if you consider 2, its reflection is 2, 2. Okay. Again, that should be included in this relation. Again, 3, 3. So that is present here. 4, 4. That is also present here. म्हणजे काय, प्रत्येक इलेमेंटचं जे काय रिफ्लेक्शन येतं, that should be present in that given relation. If it is containing for all the elements, then only that relation is called as reflexive. Now here all such order pairs are present as 1, 1, 2, 2, 3, 3 and 4, 4. That's why this given relation is a reflexive relation. आता suppose इथे जर तुमच्या सेट मध्ये 4 इलेमेंट आहेत. ओके, 1, 2, 3, 4. आणि तुमच्या रिलेशन मध्ये जर देताना ऑर्डर पेअर 1, 1, 2, 2, 3, 3 तीनच ऑर्डर पेअर दिल्या तर ते रिलेशन रिफ्लेक्सिव्ह होत नाही, बिकॉज ऑर्डर पेअर 4, 4 इज मिसिंग देअर. जर प्रत्येक इलेमेंट साठी जर रिफ्लेक्सिव्ह ऑर्डर पेअर तिथे असेल तरच तुमचं रिलेशन इज रिफ्लेक्सिव्ह होतं. समजलं का आता?
Yes, ma'am.
Okay. Now, second property is a symmetric property. So, a relation R in set X is called as symmetric if for every x, y in capital X, that is in set X, whenever X is in relation R with Y, then Y is in relation R with X. So what is meaning of this property? Symmetric कधी म्हणणार आहे आपण? If there is any order pair 1, 2 belongs to relation R, then there must be 2, 1 in relation R. Then only we are going to say that this is a symmetric property. 1, 2 असेल तर त्याचा रिव्हर्स करायचं. जसं आपण इथं घेतलंय, X is in relation R with Y. X, Y ही जर ऑर्डर पेअर असेल तर आपण चेक काय करणार आहे? वेदर Y, X is there in relation R. If it is so, then we are going to say that this relation is satisfying symmetric property. Just like if 1, 2 is there in relation, then 2, 1 must be there in relation. Then only we can say that this given relation is a symmetric relation. Now, consider here, if you check order pair 1, 1, 1, 2. आता 1, 2 हा जर फर्स्ट आपण एक एलिमेंट घेतला तर त्याच्यासाठी रिव्हर्स काय येणार आहे त्या ऑर्डर पेअरचा? 2, 1. नाउ हियर for this order pair 1, 2, 2, 1 is present. That's why this relation is a symmetric relation. Okay. Now consider this example. Now check here. For this order pair 2, 3, whether 3, 2 is there? Yes, that is present here. Okay, fine. Now for the next order pair 2, 4, whether 4, 2 is here? No, 4, 2 is not included here. That's why this relation is not a symmetric relation. प्रत्येक ऑर्डर पेअर साठी जर आता तुम्ही 2,2 घेतला, what is the reverse for this order pair? 2,2 only. That's why we are not going to consider for this order pair. Now 2,3, 3,2. Okay, its reverse is 3,2 and that is present over here. So up to this it is fine. It is a symmetric relation. Now check for the next order pair. That order pair is 2,4. Now check whether its reverse, that is 4,2, is present here. No, that is not here. That's why this given relation is not a symmetric relation. Have we understood what is meaning of symmetric property? We have to check for reverse of each and every order pair. ती ऑर्डर पेअर आणि त्याचा रिव्हर्स दोन्ही पण प्रेझेंट असतील तर आपण त्या रिलेशनला सिमेट्रिक रिलेशन म्हणणार आहे. Have you understood this symmetric property?
Yes, ma'am.
Yes, ma'am.
Okay, yeah, fine. So now next property is a transitive. So what is meaning of this transitive property? A relation R in set X is called as transitive if for every x comma y comma z in set X, whenever x is in relation R with y and y is in relation R with z, then x is in relation R with z. Then only we are going to say that this property is a transitive property. Okay, so we will see that with the help of example. Now consider what we have seen. If x is in relation R with y and y is in relation R with z, then x is in relation R with z. So this is a transitive property. Now we have to check whether this given relation satisfies transitive property. Okay, so we have to check this for each and every order pair. Now consider first order pair as 2,2. Okay, now we have to check for another such order pair whose first element is 2. So here 2,2 is given. So for this 2,2 we can check 2,3 or 2,4 because for these both the order pairs first element is 2 only. Okay, so if you consider 2,2 and 2,4, this 2 will get cancelled and you will get final value as 2,4. Now check whether this 2,4 is available in given relation. Yes, that is present here. So it is fine. Now again for this order pair 2,2, there is any another order pair whose first element is 2 and that order pair is 2,3. So again this 2 will get cancelled. You will get final value as 2,3. So again check whether this 2,3 is present here. Yes, that order pair is present in given relation. Now again check for whether there is any another order pair whose first element is 2. No. So till now we have just processed first order pair 2,2. Now check for second order pair and that order pair is 2,3. Now we have to check for all other order pairs whose first element is 3 and there are 3 different order pairs whose first element is 3 like 3,2, 3,3 and 3,4. So one by one we have to take this 2,3 with 3,2. So again 2,3, 3,2. So this 3 will get cancelled. You will get order pair as 2,2. So that 2,2 is present here. So again for this 2,3 we are going to check for second order pair whose first element is 3. So again this 3 will get cancelled. You will get answer as 2,3 and that is present here. So again for this 2,3, again there is another order pair whose first element is 3 So these 3 and these 3 will get cancelled. You will get answer as 2 comma 4, and that order pair is present in given relation. So likewise we can check for each and every order pair. If whatever final answer we are getting, if that answer is present in given relation, then we are going to say that this relation is a transitive relation. Have you understood what is meaning of transitive property? Hello?
Yes, ma'am.
Okay. Now here for this second example, you have to tell me whether this one is a transitive or not. Take 2 minutes, check for all the combinations of order pairs and tell me whether this one is a transitive or not. Hello. So first of all, tell me how to check whether this relation is transitive or not. First of all, we have to start with the order pair 1 comma 1. Okay. Now for this order pair, we have to find out such other order pairs whose first element is 1. Okay. So for this order pair 1 comma 1, there is one another order pair whose first element is 1, and that order pair is 1 comma 2. So again this 1 1 will get cancelled. You will get answer as 1 comma 2. Now check whether this order pair 1 comma 2 is present in this given relation. Is that is present. Okay. Now check whether there is any another order pair whose first element is 1. No. That's why we can say that processing for this order pair 1 comma 1 is done. Now check for next order pair, and that order pair is 1 comma 2. Now we have to find out such other order pairs whose first element is 2. So here two different order pairs whose first element is 2. Now consider 1 comma 2, 2 comma 1. So again this 2 2 will get cancelled. You will get answer as 1 comma 1, and that order pair is present here. Again for this 1 comma 2, there is another order pair whose first element is 2, and again this 2 2 will get cancelled. You will get answer as 1 comma 2, and that order pair is present here. So till so far we have done processing for first two order pairs. Now next order pair is 2 comma 1. So again for this order pair we have to find out any another order pair whose first element is 1. So again there are two different order pairs. So 2 comma 1 and 1 comma 1. So again this 1 comma 1. So 1 1 you will get cancelled. 2 comma 1 is a final answer, and that answer is present here. Again for this 2 comma 1, other order pair is 1 comma 2. So again 2 comma 1, 1 comma 2, this 1 1 will get cancelled. You will get answer as 2 comma 2, and that is present here. Okay, so here we have done processing for 3 order pairs, 1 comma 1, 1 comma 2, 2 comma 1. Now next order pair is 2 comma 2. Again for this order pair we have to check whether there is any another order pair whose first element is 2. Yes, there is one order pair. So 2 comma 2 and 2 comma 1. So this 2 2 will get cancelled, and final answer is 2 comma 1. And this order pair is present in this given relation. That's why this relation is transitive relation, because it satisfies transitive property for each and every order pair from this relation. Okay. आता जर तुम्ही 3,3 घेतला तर तिथे अजून कोणती वेगळी ऑर्डर पेअर आहे का ज्याचा फर्स्ट इलेमेंट 3 आहे? नो. सो वी आर गोइंग टू स्किप हियर. अगेन 4,4. नाउ चेक फॉर एनी अनदर ऑर्डर पेअर हुज फर्स्ट इलेमेंट इज 4. नो. That's why we are going to skip this order pair 3,3 and 4,4. So for all these remaining order pairs, it's satisfying transitive property. That's why this relation is transitive relation. So why we have skipped this order pair 3,3 and 4,4? Because here in the definition what they have said, for every x belongs to x and y belongs to x and z belongs to x. If x is in relation R with y and y is in relation R with z, म्हणजे काय, जर तिथे ऑर्डर पेअर असे असेल 1,2 and 2,1, then it is compulsory that your relation must include order pair 1,1. But if you observe here only order pair 3,3 is there, but there is no such another order pair whose first element is 3. That's why we are going to skip this element. Again for next order pair 4,4. So again there is no any order pair whose first element is 4. That's why we are going to skip these two order pairs. जर दोन्ही ऑर्डर पेअर असतील, जसे इथं आहे 1,2 and 2,1, दोन्ही पण ऑर्डर पेअर आहेत. दॅट्स वाय 2 2 कॅन्सल केल्यानंतर रिझल्ट काय येणार आहे 1,1. जर 1,1 पण रिलेशन मध्ये असेल आणि ह्या दोन्ही ऑर्डर पेअर पण असतील, देन ओनली वी आर गोइंग टू से दॅट दिस रिलेशन इज ए ट्रान्झिटिव्ह रिलेशन. आता समजलं का व्हॉट इज मीनिंग ऑफ ट्रान्झिटिव्ह प्रॉपर्टी? हॅलो हॅलो.
Yes, ma'am.
Okay. Now next property is a irreflexive property. Now this property is exactly opposite to reflexive property. Irreflexive का म्हटलं? आपण reflexive साठी काय बघितलं? If for every order pair x comma x belongs to relation R, then only that relation is reflexive. Okay. Now here irreflexive means a relation R in set X is called as irreflexive if for every x belongs to X, order pair x comma x should not belong to relation R. So this is the difference. For reflexive, what we have said, x comma x must belong to relation R. But for irreflexive, a order pair x comma x must not belong to relation R. So this is a irreflexive. suppose there is one set and that is containing elements as 1 and 2, and your relation which is defined on set X is given as 1 comma 1 and 2 comma 1. Now we have to check whether this relation is इंटरफ्लेक्सिव्ह. आता इंटरफ्लेक्सिव्ह आपण कधी म्हणणार आहे, एक सुद्धा ऑर्डर पेअर नकोय, जसे की 1,1, 2,2, 3,3 and 4,4. Now this relation is defined on set 1,2. So a relation should not include any order pair 1,1 or 2,2. Then only we are going to say this relation is a इंटरफ्लेक्सिव्ह relation. Okay. तशी कुठलीही ऑर्डर पेअर नकोय ज्याच्यामध्ये रिफ्लेक्सिव्ह प्रॉपर्टी असेल, देन ओनली दॅट रिलेशन इज कॉल्ड ॲज इंटरफ्लेक्सिव्ह. नाउ हियर वन नोट इज गिवन अँड दिस नोट इज व्हेरी इम्पॉर्टंट. एनी रिलेशन विच इज नॉट विच इज नॉट रिफ्लेक्सिव्ह, इट इज नॉट नेसेसरीली इनरिफ्लेक्सिव्ह. म्हणजे याचं मिनिंग काय, जर तुमचं रिलेशन रिफ्लेक्सिव्ह नसेल तर ते इनरिफ्लेक्सिव्ह आहे असं नाहीये. इट माइट बी नायदर रिफ्लेक्सिव्ह नॉर इनरिफ्लेक्सिव्ह. ओके, तर तसंच एक एक्झाम्पल दिलं येतं. सपोज वन सेट इज गिवन अँड दॅट इज कंटेनिंग 3 elements 1, 2, 3. Okay, and relation S is defined on this set as 1,1, 1,2, 3,2, 2,3 and 3,3. Okay, now we have to check whether this one is reflexive or irreflexive. Okay, so in order to check whether this one is a reflexive, it must include all order pairs as 1,1, 2,2, 3,3. But here 1,1 is given and 3,3 is given, but 2,2 is not here. That's why this is a not reflexive relation. One point is cleared. Now second, we have to check whether this one is a irreflexive relation. This is not a irreflexive relation too. Why? Because 1,1 and 3,3, these are the elements from reflexive. So this is not a reflexive. We can say this is not or neither reflexive nor irreflexive. कुठलीच प्रॉपर्टी सॅटिस्फाय करत नाही. रिफ्लेक्सिव्ह म्हटलं तर तिन्ही ऑर्डर पेअर पाहिजेत, 1,1, 2,2, 3,3. बट हियर 2,2 इज मिसिंग. दॅट्स वाय दिस इज नॉट ए रिफ्लेक्सिव्ह. आता इन रिफ्लेक्सिव्ह का नाही आहे? व्हॉट वी हॅव सीन, इन रिफ्लेक्सिव्ह रिलेशन शुड नॉट कंटेन एनी ऑर्डर पेअर x, x. म्हणजे काय, 1,1 हा एक जरी इलेमेंट त्यामध्ये आला तरी ते इन रिफ्लेक्सिव्ह होत नाही. But here this relation containing 2 such elements 1,1 and 3,3. That's why this given relation is neither reflexive nor irreflexive. Have we understood this? What is meaning of irreflexive? Hello?
Yes, ma'am.
Okay. Now the last property is a antisymmetric property. A relation R in set X is called as antisymmetric if for every x and y in capital X, whenever x is in relation R with y and y is in relation R with x, then x is equals to y. जर असं असेल, for every 2 elements x and y, x is in relation with y and y is in relation with x, then x is equals to y. If both are having same values, then only we are going to say that that relation is a antisymmetric relation. Okay, so these are the some properties of relations. Now we will summarize within 5 minutes what are these properties. So there are 5 different properties of binary relations. First one is reflexive, then symmetric, then transitive, then irreflexive, and last one is a antisymmetric. So for first property, that is for reflexive, we have seen a relation is said to be the reflexive if it is containing order pairs x comma x belongs to R for every x in capital X. जर त्या सेटमधल्या प्रत्येक एलिमेंटसाठी order pair असेल, like if your set is containing element as 1 and if your relation is containing order pair 1 comma 1, then we can say that that relation is a reflexive relation. Okay, so this was the first property. Now second property was symmetric. So symmetric means what? If there is any order pair x comma y, then y comma x must be there in relation R. Then only we can say that that relation is a symmetric relation. इथे आपण काय म्हटलं, whenever x is in relation R with y, then y is in relation R with x. So here we can define this one as, if there is any order pair x comma y belongs to relation R, then y comma x must belong to that relation R. Then only we can say that that relation R is a symmetric relation. Then next was transitive property. So again for this transitive, we have to check for any three elements x, y and z, if x is in relation R with y and y is in relation R with z, then x must be in relation R with z. Then only we can say that this is transitive relation. Now next property was irreflexive relation. So for this irreflexive property, there should not be any element x comma x belongs to R. Then only we can say that that relation is a irreflexive. And last property was a antisymmetric. So again, if x is in relation R with y and y is in relation R with x, then x is equals to y. If this property is satisfied, then we can say that that relation is a antisymmetric property. So these are the properties of binary relations, and this is very important point, as in each and every question paper they have asked 8 to 10 marks based on this point only. So make it clear here only. So I hope we have understood all the properties. So we are going to solve now some examples based on properties of binary relations. So here one question is given, show whether following relations are transitive. So relation R1 is given, R2 is given and R3 is given. So we have to find out whether these relations are transitive. If you consider relation R1, so 1 comma 1 is there. So what we have seen for transitive relation, if there is any order pair x comma y and y comma z, then only we are going to check whether x comma z is present in given relation. But if you observe here, relation R1 is containing just one order pair as 1 comma 1. There is no any another order pair. That's why we are going to say that R1 is a transitive. जर एकच ऑर्डर पेयर असेल तर ते ट्रान्झिटिव्ह असणार आहे, बट इफ बोथ दी ऑर्डर पेयर्स आर अवेलेबल, then only we are going to check whether it is satisfying transitive property or not, and such a case is available in relation R2. Now check here, two order pairs are given, okay, 1 comma 2 and 2 comma 2. So this 2 will get cancelled. You will get final value as 1 comma 2, and that order pair is present in this given relation R2. That's why R2 is a transitive relation. Now check for R3 whether this one is a transitive. So here consider first order pair as 1 comma 2. Now we have to find such another order pairs whose first element is 2. So two another order pairs are available whose first element is 2, 1 comma 2, 2 comma 3. So here this 2 will get cancelled. You will get answer as 1 comma 3. That is available here in relation R3. Now check for the next order pair, that is 2 comma 1. So 1 comma 2 and 2 comma 1. Again this 2 will get cancelled. You will get final answer as 1 comma 1. But that order pair is not present here in R3. That's why R3 is not a transitive relation. Have we understood this example? Hello?
Yes, ma'am.
Okay. So now we have to check whatever properties we have seen. We have to check all those properties for these examples. So here set is given and that is containing 4 elements 1, 2, 3, 4, and we have to decide whether it is reflexive, whether it is symmetric, antisymmetric or transitive. Okay, so we have to check for all the properties. So first one is given. This relation is containing order pairs 2 comma 2, 2 comma 3, 2 comma 4, 3 comma 2, 3 comma 3 and 3 comma 4. Now start with the reflexive property and tell me whether this one is a reflexive. Reflexive आहे का ते?
नाही.
Why it is not reflexive? When that
4 comma 1 and 4 comma is
1 comma 1 and
is 1 comma 1 and 4 comma 4 are missing. Okay, so that's why this relation is a not reflexive relation. Now check for a symmetric property. Check for reverse of each and every order pair. If reverse of those order pairs are present in given relation, then we can say that that relation is a symmetric. Like for the first order pair 2 comma 2, its reverse is 2 comma 2, that is present here. 2 comma 3, reverse is 3 comma 2, that is also present. 2 comma So check whether this one is a antisymmetric. What we have seen for Hello? Am I audible? Hello?
Yes, ma'am.
Okay. So for this antisymmetric, what we are going to check 2 comma 3. Then we have to check whether 3 comma 2 is there. Okay, 3 comma 2 is here, but check whether 2 is equals to 3. No, that is not equals to. What we have seen for this antisymmetric, if your relation is containing x is in relation R with y and y is in relation r with x, then x is equals to y. म्हणजे काय, जर तुमच्या ऑर्डर पेअरमध्ये एक्स रिलेशनमध्ये ऑर्डर पेअर्स एक्स कॉमा वाय अँड वाय कॉमा एक्स असतील, देन what is meaning of this, x is equals to y. But if you observe here, 2 is not equals to 3, that's why this is not a antisymmetric relation. समजलं का? जर तुमचा आन्सर असा असेल 2,2, so what is the reverse for it? 2,2 only. So here we can say that 2 is equals to 2, that's why this is a for this pair only it is a antisymmetric. Okay, but here 2,3 and 3,2, so we cannot say that 2 is equals to 3, so this is not a antisymmetric. Now check for the next property, transitive. Again we have to check it for each and every order pair. 2,2 असेल, then we have to find out all such order pairs whose first element is 2. Now for this 2,2, there are two different order pairs, 2,3 and 2,4. So this 2 will get cancelled, you will get answer as 2,4, that is present here. Again for this second order pair 2,3, 2,2 will get cancelled, you will get answer as 2,3, and that is present here. Now if you consider the next order pair 3,2, कुठेपर्यंत बघितलं 2,2 चे झाले. ओके, नेक्स्ट वन इज 2,3. नाउ वी हैव टू चेक फॉर एनी अनदर ऑर्डर पेअर हुज फर्स्ट इलेमेंट इज 3. आता 2,3 घेतलं तर दोन ऑर्डर पेअर आहेत ज्याचा फर्स्ट इलेमेंट 3 आहे. सो वी कॅन पेअर दिस 2,3 विथ 3,2. सो अगेन दिस 3 will get cancelled, you will get answer as 2,2, and that is present in given relation. Again for this 2,3 we can take another order pair as 3,2. So again this 3 will get cancelled, you will get answer as 2,3, and that is present here. So we have done processing of first two order pairs. Now check for next one, and that order pair is 2,4. Again we have to find out whether there is any another order pair whose first element is 4. No, so we are going to skip this order pair. Now check whether 3,2, so check whether there is any another order pair whose first element is 2. Yes, there are three different order pairs whose first element is 2. So 3,2, 2,2, 2 will get cancelled, you will get answer as 3,2, and that is present. Again 3,2, 2,3, 2 will get cancelled, you will get answer as 3,3, that is also present. Again 3,2, 2,4, 2 will get cancelled, you will get answer as 3,4, and that is present here. So we have done here processing of first 4 order pairs. Now check for next one, 3,3. So again for this order pair 3,3, we have to check for another order pairs whose first element is 3. So here two different order pairs are there whose first element is 3. So 3,3 and 3,2. So 3 will get cancelled, you will get answer as 3,2, that is present here. Again 3,3 and 3,4. 3 will get cancelled, you will get answer as 3,4, that is present here. Now just one order pair is remaining, that is 3,4. Now check for whether there is any another order pair whose first element is 4. No, there is no such element, that's why we are going to skip this order pair. So this given relation is satisfying transitive property for all these order pairs, that's why this is a transitive relation. Have you understood how to check for all the properties of binary relations?
Yes, ma'am.
Yes, ma'am.
Okay. Now give me present T. After that we will solve remaining example. Roll number number 1,
Yes, ma'am.
2, 3, 4, 5.
Present.
4 is present. Okay. 5, 6, 7, 8, 9,
Yes, ma'am.
10, 11.
Yes, present, ma'am.
10 is present or 11 is present.
11
Yes,
present.
ma'am.
Okay. 12
11 is present.
is 11 is present. What about 10? Roll number 10.
10 is also present.
Okay. 10 is also
10 is
present.
also present, ma'am.
Okay. 12, 13, 14, 15, 16, 17, 18, 19.
Present, ma'am.
18 is present. Okay. 19, 20, 21,
Yes, ma'am.
22,
Present,
23.
ma'am.
Okay.
I'm
23
22 present.
is, I have marked you as present. 23, 24,
Present, ma'am.
25,
Yes, ma'am.
26, 27, 28, 29.
Present, ma'am.
28 is present or 29?
28.
Okay. 30, 31, 32, 33.
Present, ma'am.
32 is present. 33. Okay. 34, 35, 30.
Present.
Okay. 36, 37, 30 is 36, 37, 38.
Present.
37 is present. Okay. 38,
Present.
39,
Yes, ma'am.
40, 41, 42, 43,
Present.
44, 45, 46, 47, 48, 49, 50.
Present.
Yes,
Okay.
ma'am. 48 present.
Present.
48 present. 49,
Present, ma'am.
50,
Present, ma'am.
51,
मॅडम 51 आत्ताच लेफ्ट झालाय नेटवर्क इश्यू आहे.
okay, 52, 53, 54, 55, 54, 55,
Ma'am.
56,
Yes, ma'am.
57, 57, 58, 59, 60,
Present, ma'am.
61. Who is present?
Present, ma'am.
60.
60 present.
Okay,
61
61,
present. Present.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65, 66, 67,
Yes, ma'am.
68, 68, 69.
Present, ma'am.
Okay. Who is present?
Ma'am, roll number 19.
Roll number
Ma'am, roll number
19,
26.
26.
Roll number 3.
Hmm.
Ma'am, roll number 40.
Roll number 19,
हा
ma'am.
प्रेझेंटी घेताना कुठे होता तुम्ही?
मॅम रेंज
आता जॉईन झालाय
प्रॉब्लेम
का?
आहे त्यामुळे आवाज येत नव्हता.
ओके. रोल नंबर 40. नेक्स्ट.
16. Roll number 3.
रोल नंबर 3. रोल नंबर
3.
16. ओके.
37.
37.
Roll number
34.
19.
ओके. 34.
Roll number 18.
18. ओके.
Roll number 19.
2, ma'am. Hello, ma'am.
Roll number 2. Yes, roll number 2 is taken. 19 is also present. Over. Okay. Now, take this second example given in question B and find out different properties satisfied by this relation. Start from reflexive. So first question for you, whether this one is a reflexive relation.
Yes, ma'am.
Yes. Why?
1, 1, 2, 2, 3, 3, and 4, 4 are present there.
Okay, correct. Now second question, whether this one is a symmetric.
Yes, ma'am.
Why?
For 1 comma 2, 2 comma 1 is present,
Okay,
and other are
good. Other are, again if you take reverse, you will get same order pairs. That's why this one is a symmetric. Now check whether this one is a anti-symmetric. What is meaning of anti-symmetric? If your relation is containing order pair
No,
1
ma'am.
comma 2, no, yes, this is not a anti-symmetric because here one order pair is present 1 comma 2, again 2 comma 1 is there, but its meaning is not like 1 is equals to 2. That's why this is not a anti-symmetric. And now check whether this one is a transitive.
yes, madam, it is transitive.
Yes, correct. This is a transitive relation. Now, check next example. This is containing two order pairs 2 comma 4 and 4 comma 2. Now check what are the different properties satisfied by this relation. Whether this one is a reflexive.
No.
Not reflexive.
No, because there is no such order pair present. Now, second one, whether this one is a symmetric.
Yes, ma'am,
Yes.
symmetric.
because reverse is present. 2 comma 4, its reverse is 4 comma 2, and that is present here. That's why this is a symmetric. Now check whether this one is irreflexive.
Yes, madam.
Yes,
In
correct.
reflexive.
कारण रिफ्लेक्सिव्ह साठी जे ऑर्डर पेअर लागतात लाईक 1,1 2,2 देर इज नो सच ऑर्डर पेअर दॅट्स वाय दिस वन इज ए इन रिफ्लेक्सिव्ह नेक्स्ट वन इज antisymmetric. Whether this one is antisymmetric.
No, ma'am.
No, because
Ma'am.
2 comma 4 its reverse 4 comma 2 is present, but 2 is not equals to 4. That's why this is not a antisymmetric. And now check for a transitive. Whether this one is a transitive.
Not transitive.
Not transitive. Why?
2 comma 2 is not present.
Yes, correct. 2 comma 2 is not here in this relation. That's why this is not a transitive relation. Good. Now take this next relation. Again find what are the properties satisfied by this relation. Check for reflexive. Reflexive आहे का?
No, ma'am.
No. Okay. Now next one, check for symmetric.
No symmetric.
No, ma'am.
Reverse is not available. Now third property, check whether it is a transitive.
No transitive.
Oh, no transitive. Because if you consider 1 comma 2, 2 comma 3 is present here. But if you cancel this 2 and 2, you will get 1 comma 3. But that order pair is not present in this given relation. That's why this is not a transitive relation. Now check for whether this one is irreflexive.
Yes, ma'am.
Yes,
Yes, ma'am.
Yeah, correct. And last one, antisymmetric.
Yes, ma'am.
Yes, ma'am.
Yes, this is a antisymmetric. Good, very good. I think this is a second last example. Again, a relation is given. Now check whether this one is reflexive. Yes, this is reflexive because it is containing order pairs 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, and set is containing elements 1, 2, 3, 4. म्हणजे काय त्या प्रत्येक सेट मध्ये प्रत्येक एक्झाम्पल साठी प्रत्येक एलिमेंट साठी ऑर्डर पेअर आहे रिफ्लेक्सिव्ह प्रॉपर्टीची लाईक 1 comma 1, 2 comma 2, 3 comma 3, and 4 comma 4. That's why this one is a reflexive relation. Now check whether this one is a symmetric.
Yes, ma'am.
Yes. Now check whether this one is a transitive.
Yes, ma'am. Transitive.
Yes, transitive. Now check whether this one is a antisymmetric.
No, ma'am.
No, ma'am.
And irreflexive.
No, ma'am.
No.
No.
And last one. Again you have to check whether this one is a reflexive. Reflexive आहे का हे relation?
No.
No, ma'am.
Because there is no such a reflexive element present. Now second, symmetric.
No.
Yes, reverse is not present. That's why not symmetric. Now third one, transitive.
Not transitive.
Not transitive. Then antisymmetric.
Yes, ma'am.
It is a antisymmetric.
Antisymmetric.
Why?
No, ma'am.
If your answer is yes, justify. If your answer is no, again justify. का एंटीसिमेट्रिक नहीं है?
आहे मॅम आहे.
It's meaning 1 is not equals to 3. 1 and 3 are not equal. That's why this is not a antisymmetric. Now check for last property. Transitive वाला आपण check केलं. Interflexive. Interflexive आहे का given relation? Guess what? Whether this one is interflexive. There is no any reflexive element. That's why this one is a end reflexive. End reflexive property साठी आपण काय शकतो? चेक करतो whether there is 1, 1, 2, 2, 3, 3, 4, 4 like this. But there is no such element available here. That's why this one is a end reflexive. So in this today's lecture, we have seen what is the relation, then what is the domain and range of relation, then what are the different properties of relations. Okay, in that we have seen 5 different properties as reflexive, symmetric, transitive, then and irreflexive and antisymmetric. Okay. So today we are going to stop here. In next